This video is about a relationship between exponential and logarithmic functions. One way to think of logarithms is a special method to write exponential. We use logarithms in very special situations. They're used typically when we're using sound measurements or when we're measuring earthquakes, because the measurements are very segregated in how much distance is between the actual measurements. It's a very wide component in the measurements, and so that's a very intense type of measurement, and so we use logarithms a great deal in those types of measurements. You can see them used in other cases, but in particular you'll see logarithms used quite a bit with earthquakes and sound measurements. We think of logarithms and exponential functions as inverses of each other. When something is an inverse of each other, then that means that you can use one to write the other and the other to write the other function. So let's look at that relationship. So if we have the exponential 3 to the x power equals 9, then you're thinking to yourself, to solve that problem, 3 to what power would be 9, and you could easily solve that as x equals 2. So you have the problem 3 to the second power equals 9. Now if we wanted to rewrite that exponential problem as a logarithm, what we would do is we would write log. This base of that exponent is 3, so the base of the log is 3. The answer that we got was 9, so we're doing log base 3 of 9 equals what exponent? And that is the 2. So these are the inverses of each other. This is the exponential form. This is the logarithmic form. So that is the relationship that exponential and logarithms have to each other. So that's one of the first skills that you want to be able to do, is to rewrite your exponentials as logs. So let's look at a couple of examples. We have 2 to the 4th power equals 16, and we have 10 to the negative 3 equals 0.001, and we want to rewrite those as a logarithm. So again, we're going to use the word log. The base is the base of the exponent, so that's 2. The answer to that exponent was 16, and the exponent part was 4. So this exponential problem rewritten as the log. All right, with the second example, again, we're using that word log. The base in this problem is 10. The answer that we got was 0.001, and the exponent of that problem was negative 3. So that's one of our first skills. We want to be able to look at the relationship between the inverse function of exponential to logarithms and be able to write from exponential to log form. And we want to be able to go back the other way. So now we're going to rewrite as an exponential. So we want to change from log form to exponential form. So we have the problem Let me get the problem right. We have log base 5 of 25 equals 2. To rewrite that, that means our base is 5. The exponent would be 2 equals 25. A second problem, if we have log base 10 of 100 equals 2. The base is 10 to the power 2 equals 100. So we've rewritten from log form to exponential form. And we can do that because they are inverses of each other. This is just a little side note, is that we consider any log base 10 as a common log. And when it is a common log, because we use base 10 number system, then we do not have to actually physically write the base 10 number. We can just use the number, just the value of log. So we could write this as log 100 equals 2, and it's understood to be base 10. If it's any other base than 10, you do have to put the subscript there. But if it's base 10, you don't have to put the subscript. It is understood to be base 10. A problem we have with that is that calculators are only set up to use base 10 in your calculators. And because they only use base 10, then we have to have some method so that we can utilize our calculators in order to actually use the logarithmic tools in our calculator. So we have a technique that's called change of base. So if we have a problem such as log base 3 of 12, and we wanted to evaluate that problem using our calculator, we would use the change of base formula. And so first we would rewrite it using our base 10 log, and we'd use this value first, log of 12, and divide it by the subscript log base 3. Now both of these are the common logs, and so we can use that in your calculator. So you would put log of 12 in your calculator, hit the divide key, log of 3 in your calculator, and you could evaluate that value to be 2.26 and get an actual numerical value for your log 3 base 12. Now this is one that's not a perfect value like some of the ones we've been working with here, and that's when we want to use the change of base. If it's one of these perfect values, we should be able to do those in your head, and you should be able to evaluate those on your own without the use of your calculator. Well, we talked earlier in our last video about the special value e. It also has a special log value for its inverse, and that is natural logs. And a natural, you could write log base e, but you can also use what's called LN, which stands for natural log. And so that's a little easier to use than log base e for our special value of e. And we can use natural log with our change of base formula. And so we could do natural log of 12 divided by natural log of 3. And you have that key also on your calculator, and it would still calculate to give you the same value. So just remember that whenever you're using that E value in a problem, it is matched up with that natural log. So those are our relationships between exponential and logarithmic problems. The last thing I want to look at is for you to be able to do some evaluating in your head. So if we had a problem that said log base 2 of 4, that means that you're kind of thinking in your head, you're wanting to figure out what that means. Then you're thinking in your head 2 to what power is going to give you 4. So what power would 2 need to be to give you 4? So the answer to that would be 2. So that's a way to evaluate that problem. So you should be able to do some evaluations in your head without the use of a calculator if it is perfect values. So that's just an example of one that you might be able to do in your head. Now I want you to also think of negative exponents as the fractional value. So if we had log base 2 of 1/4, and we wanted to know what that evaluated, since this was 2, it's 2 to what power is going to give you 1/4. We want to look at that denominator. 2 would get us the power of the fourth, but because it is a fraction, use the negative exponent to make the fraction. So that would be -2. So I want you to think about that as you're doing evaluations of logarithmic problems. So that finishes up our relationship of exponential and logarithms. We've looked at how they are inverses of each other. We should be able to write an exponential as a log as an exponential. We've looked at how to use the change of base formula so that we can calculate non-base 10 logs in the calculator. We've looked at the relationship between the special E exponential value and natural logs and how to use the change of base formula with that. And we've also looked at how to evaluate logs without a calculator.